There are many natural phenomena that happen in our world today. Lightning, tornadoes, auroras, electromagnetic pulses. I only could investigate one, so I chose to investigate auroras. Here we go.
Auroras have been around since the dawn of the Earth, but it is not until recently that some fictional tales will put to rest. Since about 1880, scientists believed that sunspots and auroras could be connected, though it was not until 1950 that scientists were able to conduct an experiment to prove this.
An aurora is a natural display of light, usually occurring 50 to 400 miles above the Earth's surface.
Scientists now know that during solar storms, the sun emits protons and electrons. Solar storms are large-scale magnetic eruptions which call coronal mass ejections and are associated with solar flares. Solar flares accelerate the charged particles into the solar atmosphere at high velocities. These particles continue to hurtle towards the Earth by means of solar wind. Most of these particles are deflected harmlessly by the Earth's magnetic field, but some of the energized particles make their way into the Earth's atmosphere. These particles enter through weaker parts of the Earth's magnetic field, which are located above the North and South poles. When the particles enter the Earth's atmosphere, they collide with gases in the Earth's atmosphere. As the charged particles collide with the gases, the electrons in the gas are excited because they receive extra energy. This extra energy that excites electrons moves an atom's electrons to a higher energy level. Soon after being excited, the electrons return to their normal state. As the electrons drop back to their unexcited state, they release energy in the form of photons. Photons are particles of light which are part of the quantum of electromagnetic radiation. Depending on which gas the sun's charged particles collide with, the color presented in the atmosphere changes.
Oxygen and nitrogen are the two most common gases in the Earth's atmosphere. When oxygen's electrons fall back to their normal state, the color presented is green or red. When nitrogen's electrons fall back to their normal state, the color presented is blue. Combinations of the two gases can create beautiful pinks and purples that we see in the night sky today.
Other planets in the solar system have auroras as well. Jupiter is an excellent example of a planet with an aurora because it has massive and stunning displays. Moreover, auroras can be seen on any planet with a magnetic field and an atmosphere. Mercury and Venus have no traces of aurora signs because Mercury does not have an atmosphere nor a magnetic field, while Venus does not have a magnetic field. Therefore, these planets so far do not have auroras. Auroras today can be seen close to the North and South poles. The auroras in each pole mirror each other in time, shape, and colors. To have the best show of auroras, one needs to go to a place with no light pollution.
So, there's supposed to be an aurora tonight. I know what's happening, and now you do too.